Hi, welcome to Visual Studio Toolbox. I'm your host, Robert Green, and joining me today is Lance McCarthy. Hey, Lance, how are you?
Hey, Robert. Thank you for having me on the show today.
Thanks for coming on. Thanks for coming back on the show. It's been a while since you've been on, so welcome back.
Hey, lots has happened.
Yeah,
Lots to talk about, but we're going to focus on one thing today, right?
excellent. We are going to focus on the container tooling in Visual Studio. But before we do that, why don't you introduce or reintroduce yourself to the folks watching in case anyone doesn't know who you are?
My name is Lance McCarthy. I am from Boston. I'm a Windows developer in .NET Microsoft MVP. I've been doing Windows Phone development from the very beginning, and then that evolved into Windows 10 development and then Windows 11, and you have all the traditional stuff there. But primarily, I really love C Sharp. I love .NET and Visual Studio tooling, and that is the core of what I do. But I'm a hackathon veteran, love hacking at code, playing with tools, and during the day, I'm a senior manager of technical support at Progress Software,
Excellent.
which you might know as Telerik or Kendo. That's
Hmm.
the products that I cover.
Cool. So the ability to run apps in containers has been around for quite some time. Um, and people need to manage their containers and do their Docker files and whatnot. You told me that you're finding that most people are tending to use the CLI and just type a bunch of commands, but it turns out that there's great tooling inside Visual Studio for working with containers. Do I have that right?
Yep. And I thought that would be a great topic for today. Developers, they have muscle memory for the CLI, and you don't necessarily need to.
Mhm. It's kinda the same thing with things like Git or back in the day working with Azure. There's always the ability to do it from the command line, but the tooling written by folks that are just as, if not way more familiar with the commands you'd have to type than you are, build tooling so you don't have to do that stuff if you don't want to.
Exactly. I think the Git comparison was perfect. Right? That's exactly kind of what's going on here. And it's your preference. And some people think one is faster, the other is faster. They tend to be around the same.
Mhm.
I find that I use them both in various scenarios differently. But when I'm in Visual Studio, I like having everything in one context. And
Right.
that really helps keep you focused.
Cool. So you got a app that we're gonna look at and then show us the tooling. So when you're ready, you can share your screen.
We're just going to start by opening Visual Studio, and there's an ASP.NET app in there. The app doesn't do anything special, right? Today's demo is not about what the app or .NET is doing.
Mhm.
It's about the outcome of when it's done being compiled. The great thing about ASP.NET Core is you can run it in a container,
Yep.
but you need to build that image, right? And how you build that image can be done in one of two ways. It can be done through the .NET SDK now. You can have these things inside your CS proj and it will build as a container, or you can use a Docker file. Today, I'm using a Docker file because it will let me show you a little more of what's going on inside of it. But again, that's not really the important takeaway here. What's important is what we'll see in this pane down here as we're using containers and looking at our local images.
Okay, cool.
So just to start off, right, we're not looking at anything with the project. This is just the containers tab, which you will find under view, right? You go under view, it might be up here, it might be under your other windows, but you'll find the containers tooling there. The first thing you'll notice is you have two lists. You have a containers list and you have an images list. And just to show you that Visual Studio is indeed synced up with the local Docker environment, I'm just going to open terminal here and show you that the containers are indeed the same. And just to make sure, we do Docker PS, which means to list the running containers, and I'll do a -A, which lists them all. It'll show running and not running containers. And you can see we have a container here, the container ID is 685B. If you look down here, this is that same container.
Okay.
So what we're seeing in Visual Studio is actually what Docker is seeing here. So we don't really need this anymore, so I'll close it. That's just kind of like the proof that it's not a special little side thing that VS is doing. It's the same subsystem. Now in the images tab, we have all of the images that are local. So I should briefly explain the difference between an image and a container. I imagine folks know, but sometimes they get intertwined or spoken about differently. An image is what gets created by your Docker file or your build. You can think of it as a detachable hard drive.
Mhm.
So you build up this hard drive, you install the software you need on it, and then you pass that hard drive out to anyone that wants to use it. And the container is like sticking the hard drive into a computer. It actually spins it up and it's a running thing. But the cool thing about images is you're not limited to just one container. You can have the same image be running in multiple containers. So that said, we can look at the images list here. I have one locally called, MCB Playground. I was working with writing some MCP servers that's running in a container. We have some that come from Docker Hub. You can see I have some stuff up on Docker Hub and some other dependencies. These are all images that are local. Some from Microsoft Container Registry. This is where we usually get our .NET runtimes. So this is like the base of the image. And a few others like up here where I have that registered. And this is my Azure Container Registry. I have one registry if I want to put images up there that I don't want public, or on Docker Hub or GitHub Container Registry.
Okay.
So I have that up in Azure too.
So the images are basically your base, your computer that comes fresh, ready to go with nothing specific to you in it. And then you add stuff to it and then you can run it in the container. That's the basic
Exactly.
flow, right?
Yeah, that would be the base image. So that's a perfect segue into looking at the Docker file.
Okay.
So let's take a look at my Docker file here. I'll scroll to the top.
And the Docker file's job is to build the container out of your image, build a new
It start
image out of a base image.
Yep. So a Docker file will start with the base image.
Mhm.
So this is like the operating system with a certain predetermined things installed.
Okay.
This one comes pre-installed with ASP.NET Runtime.
Okay.
And this whole top section here is a layer. It's called a layer without getting complex. It basically, every time you make a change to the base image, it creates a new layer, and if file changes, you can look backwards. But you can think of these as stages. That's what I've done here with these comments. So the very first stage is I pull down the base image from Microsoft, which is, I can't recall what the latest one is based on, but it's a Linux image. Used to be Ubuntu. It might be something different now. But I'm saying that this is my base. So I'm getting a hard drive, an image from Microsoft that has pre-installed the things I need to do to run an ASP.NET app. That means I don't have to install .NET. I don't have to install any dependencies, anything like that. Out of the box, I get what I need. Then the next thing I do, I take that and now I want to compile my app and kind of install my app into that image. And that's kind of what a Docker file does for you. It's instructions to build it.
Okay.
So in stage two, I have a temporary one that says, hey, just for compilation, we're going to use the SDK image from Microsoft, which is a bit bigger than the basic ASP.NET one. So this has all the build tools in it that you don't need at runtime. So I just get the SDK one and I call this stage build stage. And the stuff you see here is just setting up NuGet servers. Then I restore NuGet packages. And then I actually do a .NET publish command. And what this is doing is saying, hey, I want you to compile the app and put those published assets into a folder called app publish. That's pretty much all this stage two does. Finally, stage three says, hey, start with the base that's pretty clean, right? So my base layer here, all it does is just say, hey, my work directory is app. I want you to expose these ports, and I needed some dependencies because of the software I'm using. You
Okay.
can do all of that. This is the base of my final image. So this last one says, hey, don't use the SDK one, but use the base one as the final result of my image. I'm going to say the work directory is app. And what I'm doing here, I'm copying the code that I had compiled up here. So everything that's inside this folder, I'm publishing it into the image that I just got. So I'm saying, hey, we're in the app directory right now. take all of the compiled assets of the ASP.NET Core app and put them into this app folder. That's basically copying from here and to dot, which means current directory. The probably last thing is I'm saying when the image actually starts up in a container, the entry point of the running container is going to be run this command with this parameter.
Now, did you write that Docker file from hand by scratch? Did you have tooling that helped you build it?
I did this one from scratch, but it's only because I've become familiar with how it works over time. But you can get a Docker file from the docs. Microsoft's .NET docs has tons of examples, especially the one that's covering container builds in .NET documentation. But you can find them almost anywhere. The important part is kind of this part here. This is custom to mine. You won't see this. This means that I have a custom architecture. So I want one image for x86, one image for x64, one image for ARM64, so that my app supports all the platforms.
Mm-hmm.
But normally you only have this and you build for one target.
Okay. Does Copilot support building Docker files these days?
Copilot is actually an excellent suggestion. You can just ask, say, hey, give me a Docker file for ASP.NET 9, and it will do pretty much everything you see here minus my application.
Right.
And if you're using Copilot Agent inside Visual Studio, it has context of your application,
Mm-hmm.
and it will look at the DLL that is going to produce and help you write the rest of it too.
Cool.
Some stuff you see in here, like these secrets, this is more of an advanced topic, but if you need to use a secret in your image, you don't want to distribute that image with a password in it, right? So I need a password to connect to the Tower of Nougat server, for example. Docker has built-in abilities to mount a secret, and it doesn't stay as a permanent part of the output image. And so when that gets built, and come back over here, I think I deleted it. Yeah, I don't see it here anywhere. So if we actually do a build, it should do it here. So I'm gonna start. I should have started without debugging, but let's take a look at the output. So there's the application. It's running on localhost, and this looks like any other typical web app that you would do, but it's actually running in a container. And we can see that by the solution containers tab here. Visual Studio knows what containers are running because the solution asked for it, and we can see that. If I select it, we can see all sorts of things about the container. This is the actual startup. So if you ran a container in any environment, you would see this in your logs or your exec console. This is where the VS tooling comes in extremely helpful. If you're just using CLI, you kind of have to ask for these environment variables differently, or you can output it and it'll be a big wall of text. Instead, you can see all of your containers details right here on the right once you have a selection. You can see my environment variables, you can see where everything is. If the container has any labels, like this does, if there are any ports open, and this one's particularly useful because you have multiple containers. The image says I need to host on port 80 and 443, right? For regular HTTP or HTTPS. But you can't do that on the host operating system because they'll conflict. You can't share the same port between multiple apps. So the way Docker does it is it maps an internal port to the host port. And we can see that easily here, and we can click on it to open it to that particular point. Volumes. Volumes are kind of like, I mean, if you come from the Mac OS world or Linux, volumes makes more sense. It's kind of like a drive file system on a drive. A volume would have a particular file system. And we can see the image has multiple volumes that are mapped. So on my host operating system, I have this shared media packages folder, but inside the image, the container, we browse to it. So these are mappings that act like the same hard drive on my operating system. This is very handy because you don't have to copy paste files. Here we see a very useful thing too. These are the files of the image. And this is your copy of the image.
So that's the whole image, not just your app.
Exactly. This is the container. It started with the image. and this is the image running. Now, if I were to make runtime changes, let's say I went into the app and I connected to a database, or I made some changes for that container, it's only for that copy of the image in that running container. So it doesn't affect the base image. And if we open app, you remember in the Docker file, the last thing we said was, hey, go to a directory called app, and we're going to copy everything from the app publish folder in our build stage and copy it into the app folder. So if we open the app folder, we'll see my application's code.
Yep.
And this is where it'll actually run from.
Nice.
Inside the bin will be more, but that's the basics of it. And we can see logs. This is particularly important if you're having issues at runtime. You will see errors here, or let's see if I can maybe crash it. Let's go to my report viewer. Oh no, of course it's working.
Of course it's
But
working.
yeah. But if you see a crash, it will come here, or a warning. More often, you'll see warnings here, like these top ones. And details are about the state of the container. This isn't something a .NET dev would frequently see, but if there's some inconsistency and you're curious what the container settings are, you can find them here on the details.
Nice.
Normally, folks use a Docker CLI, are very fascinating. Docker stop, Docker start, Docker remove. All these things require kind of the ID of the container. And it can be cumbersome because you have to copy paste or move things around. When you're in the VS tooling, you just click stop. Of course, I moved the debugger, but if we go back to containers, and we can see that container is now stopped. Now, let me close the solution. After we close the solution, we can see that our containers list is not polluted with all of the debugging work that you did. The whole point was to keep it out of your main Docker environment, do what you need to do. And then when you're ready to finally publish the app as a container, you can keep the image locally, you can run it separately, but Visual Studio keeps it nice and clean is the best way to say it,
Okay.
that I don't have to worry about any of this. And that's why we kind of had this little tab here that said Visual Studio area, where the solutions containers are located. It'll clean up after itself. Other than that, we've got some more specialized tools like refresh the list of running containers, show all containers, show only the solution containers. So when we first started up, we saw that it still showed the other running containers on my system. If you're doing something like .NET Aspire, you kind of only want to see all the containers that are related to that solution, because each project in .NET Aspire becomes a container. And pruning is to remove things that are no longer being used or referenced. Same goes over here. By pruned, I would delete everything that has no use in a container, whether the container is running or not. So this is a pretty cool feature. Quickly clean it up. This is really what it boils down to, right? You don't need a PhD in Docker or container tech. It gives you just what you need when you need it when you're building a .NET app and you're targeting container environments, regardless of the end outcome of where those images are being published or what the target environment is. It's just you, as a developer, have the tools you need at the time you need them without complexity.
Cool. Now, if you're running the container, you run it locally, and then let's say you publish it to Azure, and it's running up there, can you use the same tooling to investigate the container running in production on other machines? Or is this all for testing locally?
I see. This is, as far as I know, there's no way to remote debug
Okay.
this, like connect this to a remote environment. Um, but what you could do is have a remote debugger connected to that environment, but I'm not sure you would get this kind of setup. This is kind of geared towards the Visual Studio solution
Okay.
and the containers that Visual Studio deploys.
Okay. So
But
this
that's a great question. I'm gonna follow up on that because it's no different than remote debugging in ASP.NET Core app,
Yeah.
right? Because you can attach a debugger and debug the app, but it wouldn't be the container environment that you're debugging. It's the actual
But of
app.
course, one of the main benefits of containers is that it's contained. So if it works on your machine, it literally should work on another machine because it's just the entire environment. So,
Exactly. The only
right?
consideration you need to have there is the architecture of the host.
Right.
Like if it's an ARM64 machine, but you would build an ARM64 image.
Right.
So for example, this app here, I do have published, right? So this is the same image, but it's in my Azure Container Registry. And if I could Docker run this image, it would know that my host OS is x64 and it will give me the x64 copy. But I have a Raspberry Pi rack in my 42U rack to the left of me here, and I run a lot of these there too. Those are ARM64,
Okay.
but it'll pull the right image for the environment. But if you don't have the right image, you'll get an error in the log saying bad exec. I forget the exact error code, but it'll tell you that the image is not correct for the environment.
Okay. Cool. That's pretty straightforward, pretty cool tooling. Have there been a lot of advances in the tooling lately, or they've been pretty stable?
I haven't been following like releases and the release notes of each, but as from my experience, they have just been working. It's been pretty good. Imagine that the tooling developers here are working with .NET Aspire, right? Because this kind of all evolved at the same time, right? So they're probably working closely behind the scenes. You would know more about that than I would. But yeah, generally they just work and they're right there, not complicated, and it's good to do the quick things you need to do.
Yeah. And it's the great way for someone who's relatively new to containers to start using them. And then, of course, you can learn the CLI stuff as you get more advanced or you want more controls. You can use them together.
I don't think you can, so we can't publish, right? So if I wanted to take an image I built locally and I wanna push it to Azure, that would be a command,
Okay.
or require my publishing. If I go to I've already closed the solution, but you can have a publishing profile that publishes to Azure when you do the publish, geared specifically to debugging and runtime locally, and things are working locally, and you want to have what you need there without distracting yourself over to the CLI, needing to know the ID of the container and execing into that container. Just come here, you select it, go over to console logs, and everything is there.
Sweet. So if folks are new to containers, where do you recommend they get started learning?
So there is a good, assuming that they're .NET developers, right, and you're in Visual Studio, there's
Well,
some
if they
great
weren't
doc.
.NET developers, they're probably not watching this show. So
Right? Yep. "Oh, you Java guys, what are you doing here?" Yeah. Yeah, so I'll put together, a batch of links that I think are the most helpful,
that'd be great.
and you can attach them to the show notes.
Awesome. All right. So thanks for coming on the show and showing us that really cool tooling. Appreciate you coming on. Any other closing thoughts?
This is not, complicated. It may seem scary at first, but the idea of the tooling here is just makes it easier to use. Like you said, you're getting started. And don't be afraid to use GitHub Copilot in helping you write your Dockerfile kind of things, or use the .NET container publish options. But try a container. If you're always deploying to IIS, you'll be surprised at how helpful containers actually are.
Cool. Thanks again, Lance. Hope you guys enjoyed that, and we will see you next time on Visual Studio Toolbox.
Take care, everyone.